All right, you guys have a square root function. Every type of function, you're going to get these sheets because, one, you have to know how to make an educated XY table, okay? So here's what I mean. On a square root function, it's called a square root because the root is really a 2. It's implied. So even on your calculator, you just see the little root, but there's really a 2 there. That's why through here, yellow, it's a 3 because that's a cube root. You can't see it, but whatever. Okay. Positive, negative, right? When you guys plot it in Desmos, when you type it into Desmos, they either give you the positive or the negative. They can't give you both because it's not a function, right? It's not one-to-one. All right, imaginary numbers, an imaginary root. You cannot graph that on Desmos, and that's why even on here, you're going to get a math error. Like if I take the square root of -3, I get syntax error, math error, okay? So that means that it will not graph on a real number coordinate plane, a real system. So you're going to get kicked out. Okay, so if you understand that, we'll do the table on the right. But if you don't understand that and you guys are on a test or a quiz with your partner and you're like, oh, you know, here's this, what I'm working on. This is a function. And you're like, oh, let me do -5, -3, 0, 1, 2, right? Say you go for that. And now you're going to type it in, and I get -2 square root, -5 plus 3, click out, plus 5, right? So see, I'm substituting, right? Okay, I hit equal, math error. That math error is because I have a negative root. If I go back, what's -5 plus 3?
-2.
-2. I have rad -2. That's an imaginary value. And so like this one then, you cannot do it, right? If I was plugging the -4, I get kicked out. So if you guys understand that, the real number you're going to pick up on is when you look at your function, -2, don't even care what it is. +5, don't even care. You look at what is inside your radical, your radicand. You got to look here, everything that's contained. Set that equal to 0 because that is your first value. Remember, 0 is a positive number. It's always positive. So what makes this radical a 0? -3, right? Because what's -3 plus 3? 0. So I know that at x equal -3, that's where my radical is 0. And so an educated table starts at -3. You could type in -1, 0, 1, 3, and now you have no limit on your x values that you can substitute. But you can always pick whatever numbers you want, but your key critical point is wherever that radicand is going to equal to 0, that's how you start your XY table. Because you're going to get an error imaginary values prior to that number, so that's why do you even want to graph it and waste your time with it? Okay, if I had a -4, I would get math error. If I had -10, I'd get math error, right? If I had -3.5, I'd get a math error. You have to first start your critical point at where the radicand is equal to 0. Fair? Okay, I'll stop it here. Tomorrow I'll go through the cube. And then I'll do the other video as far as I'll have you guys graph it, and then we'll go over orientation, vertex, domain, range, and behavior, intercepts, your critical points, and then we'll just make sure you guys have this down, okay? All right. Okay, let me shut off the video.